with all the current interest and discussion about a manned mission to Mars and even starting a colony there, I'd like to take some time today to just discuss some of the general problems and challenges that we face as a society if we're going to achieve this goal. And so I'm going to take some time and talk to you about some of the main problems that we face with a goal such as this and are often unfortunately skipped over in some conversations just because of our sheer excitement about the topic. So, a manned mission to Mars is going to face numerous challenges, and none the least of which is going to be high radiation levels, low gravity, long travel times because of just the distance between us and Mars, and problems with our current launch vehicles and rockets. So, my name is Kieran Scott. I'm a student at Embry-Riddle Aeronautical University, and in the fall I'm going to be starting their aerospace engineering program. And so I'm doing that because I've had a long time interest in space and space travel and just building things, and so I've done a lot of research into this topic on my own. And also for this speech, I have done a lot of research on reputable databases such as JSTOR and looked at multiple academic journals about Mars and sending people there, sending just missions to Mars. So, in this speech, I'm going to be discussing some challenges that we face, as I've previously said, and what it would be like to establish a colony or base there in terms of challenges. And so, mainly I'm going to be discussing, as I said, lower gravity, thin atmosphere, lower amounts of water, high radiation levels, distance, and even some problems with our current launch vehicles and rockets. And so this is mainly to raise some awareness to these challenges because a lot of times people forget about some of these problems that we have. We have a lot of very brilliant people working on these problems, and so sometimes people just assume that we'll be able to do it very soon, and they don't really think about the problems that we still have to overcome. And so I'm not necessarily going to be suggesting solutions to these. This is basically just an attempt from me to inform you about some of the problems that are holding us back from a manned mission to Mars. So, first, distance. Distance is one of the biggest problems that we have. It's extremely far between us and Mars. At the closest that Mars ever gets to us, it's about 33.9 million miles away. And so that only happens every 15 years or so. It's Mars has a very eccentric orbit, which means that they don't move in a complete circle. Basically, they get closer and farther to us based on different amounts of time. And so that means that at its farthest, it's also going to be 250 million miles away. And so the average distance between those two is about 140 million miles. That's basically what we're looking at when we're looking at some kind of a mission to Mars. And so what this means is that with our current launch vehicles not going that fast, and some of the problems with the launch vehicles also include, well, especially the Russians have had quite a bit of problems getting things actually to Mars. It's with the distance and as we'll talk about the time delays because of this distance and just the difficulties involved in space missions, it can be a very big problem just to get things to the planet. And so basically it's going to take 5 to 10 months for a spaceship we have right now to get from here to Mars, and that's basically the range that we look at. 5 months if it's close, 10 months if it's far. And so then obviously it's going to take more time if you want to wait for ideal windows to launch. I mean, you have things like weather. We can't launch in, like, obviously a thunderstorm or something. But also, a lot of times you need to wait for the planets to be aligned in a specific way so that you save on fuel, because fuel is a very limited resource. It's a very far distance that you're going to be having to go across. You're going to need fuel to get there. So this means that it's going to be very difficult in terms of actually getting people there. And so that distance also means that there's going to be a time delay. Because on Earth, you don't really have to worry too much about a time delay unless you're in something like business. But you do have to worry about how fast communications travel when you're talking about distances this large. Because of that gigantic distance, that means that there's a delay in communications for us, because radio waves, which we normally use for things like cell phones and radios, obviously, they travel at the speed of light, which is incredibly fast, but over distances like this, it adds up in terms of the time it would take. Which means that on average you have about 22, you have about 13 and a half to about 22 and a half minutes of delay. And so the average about that is going to be about 14 minutes. So basically that means that from the point where you've launched anything to Mars, you're going to start having a time delay, which means that if there's any kind of problem on a rocket, especially as you get closer and closer, you're going to have a bigger and bigger delay in terms of how quickly you can actually fix that problem, which obviously can be fatal in some cases for a manned mission to Mars. Because we don't have any faster than light communications, we don't really have a solution to this yet. And I mean, even something as simple as trying to have a conversation with like a relative who's gone to Mars, it's going to be a large communication difference. So imagine trying to talk to someone who's on Mars over the phone. After you say something, they're not going to hear you for about 14 minutes, and then after that, then they hear you and they can respond, and you won't even hear them for another 14 minutes or so. And that's obviously the average. Sometimes it's going to be that high of 22 and a half, and sometimes it's going to be a low of 3 and a half, which isn't as bad, but still, in emergency situations, every minute counts. And so you have to actually multiply that by 2 because it has to get there and then also get back, right? So this is something that we're going to have to work with a lot more. Obviously, NASA has overcome some of these problems with the probes that we've sent to Mars, but a lot of these, basically once were on Mars, they didn't really need us to be sending them constant instructions. It was okay that we had that time delay. So with manned missions, we're going to need a lot more autonomy, and we're going to need a lot more decision-making abilities of the people who are actually there, because we don't really know what's going to happen. There can be emergency situations anywhere. So another huge problem is the gravitational field. The gravity is just, it's lower than on Earth, which also leads to loss of bone density for humans and other animals. We're used to having an acceleration of gravity of about 9.8 meters per second squared. That's 1g. Always it's 1g pulling us down. And our bones are what help fight to keep us up off of the ground. We are constantly fighting that g. Mars has about a tenth of the mass of Earth and about a third the gravity. So that means that everywhere you go, it's going to be like the astronauts who walked on the moon, where you can kind of bounce around, and most people think of this as something that's very fun. And short term, yes, I'm sure it is very fun. But the thing is, over time, your bones don't need to be as strong to keep you up off the ground. And so what happens is you actually lose bone mass. And for astronauts on the ISS, it can be sometimes 10 times as fast as a disease like osteoporosis. It can be very, very dangerous. Now, Mars has some gravity, so it won't be that bad, but still, you will be losing a lot of bone mass. Which means that if you were ever to come back to Earth, which is an entirely different thing, I mean, we've been talking a lot about one-way trips to Mars lately, but if you were, you'd have a lot of trouble standing and just functioning as a human. You'd be kind of like a blob, almost. So that means that you have to exercise every day, multiple times a day when you're there, as the astronauts on the ISS do. And so this means that you're losing time, valuable time, to having to help your body to maintain some kind of physical fitness that's going to keep you healthy. And so obviously this time could be spent in more helpful ways, and if there's some kind of emergency happening that lasts multiple days, it could be hard to keep up with that fitness schedule. But ultimately, it's a problem that we already do kind of have a solution to. It's just more of a pain than really anything else. One of the biggest problems, though, is the weak magnetic field. And so Earth has a very good magnetic field because basically we have a liquid core that's just turning and making our magnetic field. And what magnetic fields do is they help to contain and to keep an atmosphere, and they also help to contain and keep a nice shield for radiation. And so those are going to be the two biggest problems. Radiation levels on Mars are very dangerous. There's cosmic radiation from outside of our solar system, and there's solar radiation from the sun. And without a strong magnetic field like the Earth has to deflect some of those lower forms of radiation, and things like UV get absorbed in the atmosphere, Mars is very dangerous in terms of radiation, which means that it's going to be hard to work and operate outside. I mean, we on Earth have a very high standard of how much radiation we're allowed to take in a year. This is going to be completely different on Mars because you're just going to be constantly exposed to it. Some radiation you can't ever quite stop, but you can really effectively block almost all of it, so it's insignificant. But these are still things that we have to look into because things like lead shielding are heavy, and as I've said, fuel is very important. So it's going to be difficult to be launching things like lead on our current rockets. But so that also means that the atmosphere is very thin, which means that it's hard to breathe, but it also means that there's all kinds of crazy temperature swings. Without greenhouse gases to really be keeping things in, and with a thick atmosphere to deflect that radiation, as I've already said, the temperatures on Mars, they can swing vastly, but they also are, it's very cold. The average temperature on Mars is about negative 80 degrees Fahrenheit, 80. And typically in summer, it can go from about 70 degrees Fahrenheit in the day to about negative 100 at night. So that's a huge temperature difference that we're going to have to deal with. It's a problem, but it's something we can fix. But again, it's something that's going to be difficult. And so that also means that there's a lower pressure than Earth because the atmosphere is thinner. It just means that there won't be one atmosphere of pressure as humans are used to, which means that really you're going to be needing insulated spacesuits almost for anything you do outside. And it also will mean that it's fairly dangerous for something like some kind of habitable unit to be broken, like a window almost. If it breaks, then you'd have to deal with lower pressures and lack of oxygen, cold temperatures. And there's also very little water, which is going to be a problem in itself, though there is ice on the poles, so there is some water. But so, in conclusion, there are many challenges that are inherent to traveling to Mars and sending humans to Mars. And so, while they're being assessed and worked on by a lot of the top scientists and engineers that we have, many people they almost forget about these problems when they're just talking about it in normal conversations. So, I think that it's very important for people to know and understand these problems that we have with concepts such as going to Mars and sending humans to Mars, because of how just prevalent it is in modern society. I mean, it's everywhere. And so spreading the ideas of understanding these problems and spreading these problems and telling people about both the exciting and the kind of discouraging aspects of this, I believe is really, really important. And in having an informed society who understands what they're going into when they make promises such as sending people to Mars. So I'm also hopeful that perhaps some people who hear this or who have heard of these problems maybe will have their own insights on how to solve these. So ultimately, that's why I gave this speech today, and I really do hope that you both learn something and perhaps that you will spread these problems so that other people understand what we are actually up against. Thank you.